solicit comment or input from the larger community. So I would encourage people to use that as well if they're looking. Yes. When it becomes a draft. So basically there's a section of that wiki that tracks both working group Yang models and individual Yang models. There's 2 tables. There is a separate section that lets people go on and announce their intent or desire to create a Yang model and solicit input from the community. So I would encourage everybody to take a look at it and use it as much as you can.
Okay, any other questions or comments before we move on? Okay. Oh. The slides have been uploaded, but they may not appear yet because the tool takes time. But all the slides have been uploaded. They just may not appear online yet because some of them were just uploaded about 10 minutes ago. Okay.
Yep. That's why I have the deadline a day before. I know. We're one of the first.
Okay, let me open the next slides. Okay. Luca, you're actually up without slides. So Luca is next talking about 4447 bis. Oh, Luca.
No. Doesn't work.
You just did something to the projector as you walked past it.
This works. Okay. Did it actually knock it? Or?
No, it's all automatic. Just carry on with it.
Okay. So, well, good morning. I'm surprised there's so many people in this room. 15 years to the day, actually, or well, to the meeting. There we go. About 15 years ago, that's when we first introduced the RFC 447, which was at the time called, I mean, it was still called pseudowires. Well, we we didn't even call it pseudowire at the time. It was called Draft Martini, actually. And then we created a working group called CIOTS, and that then was renamed to PWE3. And then I guess it was renamed to PALS now, and that's when I met Stuart shortly after that on a big argument about 2 bits, the second and backend bits. Exactly. Actually, I can probably say what happened then. At this point, it's been 15 years. There was a typo in the header, and so we basically reverse the second and backend bits in the PW3 header, the control word, and that caused, it was no reason, a particular reason, and so Stuart actually found that out, and then he was asking also a question: why would you reverse these bits? And we couldn't quite explain it. And the problem is that there was a typo in the header, but the problem is as soon as nobody noticed the typo in the document, and by the time Stuart brought up the problem, everybody had implemented it that way already, so there was no good reason to change it anyway. So this time, so what I did in the past, there's been two revisions actually of this RFC 4447 bis. The first one, I took all the erratas over the past 15 years, and they were accepted. There was a lot, many small technical problems, mostly text and clarifications and things like that, and I included that in the document. And then Giles took another pass at it, and we basically at this point, this document has been around for a long time. We just wanted to get a refresh to include the errata and move it to proposed standards or whatever the next step is. I believe that right now it's ready for its last call. We're not trying to include One of the things that I wanted to do in this document, I didn't want to change anything radically like text or include other references to work that's been done after the document or anything like that. It's just a very simple fix for the errata and you know, kind of update to the current template of the IETF. So that's, I think there was one thing that came up on the list. There was the order of the FAC 129 TLVs, and the question was, there's one implementation that sends it in the order that is in the picture in the draft, and there's another implementation that sends it in a random order. And the particular document does not require any order, and you know, it doesn't say it has to be in order. The reason we have TLVs is because you should be able to send them in any order you want, unless somebody specifically says there is a good reason to send in a specific order. And so I don't really feel like we need to add a piece of text that says, you know, you can send in any order, because that's implied. It doesn't say you have to send it in order, so we should be fine with that. And any other comments?
Yeah, two clarifying question. In errata, did you looked at the fixed in next release errata as well as the? There are several classifications for errata. There's reject, there's accept, which obviously you do have to do, but there's also authors to look at when the document is updated. Did you pick those up as well?
Yes, I looked at all of those. There were some that were not valid.
Well, you only have to look at them, but the commitment is that the authors will look at the ones that the ADs classified as look at in next release, as well as the ones that were approved.
Right. I went through all the full errata. They weren't accepted. There was nothing.
No, but they're not accepted. Are they accepted state? I'm not sure. I'm just making sure, because a lot of people don't. Well,
No. It was the state was always held for next revision.
That's it. Yes. Look,
I did all of the held for next revision.
Good.
There was nothing that was not, you know, that was wrong or anything like that. I can't remember. It was fine.
Now, the other thing is, did you go through all of the updated by documents and see if any of that needed to be propagated into it?
Updated by.
Well, so RFCs get updated by other RFCs.
Right.
When you do a revision, you should look at those updates and move them into the main body of the text by one way or another, so that, because otherwise the update trail is lost and people don't necessarily know what edits they need to make.
Right. That's one. Okay. So there was no update to it. There was okay. So there's the one thing that comes to mind is the control word negotiation.
Yes.
Part where it was not as clearly as specified in this particular draft as it was in the next. There's another RFC.
You need the tools version, Andy.
Sorry?
Is it?
Yeah.
Is
That's the tools version.
So usually this is...
No, this is not.
You need to go back. You need to go to a different part of the tracker. You need to go to the part of the tracker that says whether it was updated by anything.
That's not the. Yeah, that's not the last one. That one. No, that's not the last one.
That's the one you want. Right. You see the updated list there. You should incorporate those updates into the body of the text.
Okay.
Either directly or by reference, however you want to do it. Otherwise, all that information is lost, and people don't realise that the new one is...
We could do a reference on this. I'm not too inclined into putting this in the text, because some of those are fairly extensive.
Well, we'll have to just look and see on a case-by-case basis. Otherwise, the integrity of the document isn't right.
Okay. I mean, okay. So let me ask you a question here. Then, one of those RFCs, I don't remember which number it is the VCCV. Sorry, the control protocol negotiation,
yes,
which really kind of updates the whole section, which we can include those updates and obsolete that RFC with the new one that will come out.
I think that's probably the right thing to do, because...
That's just, you know, that's pretty easy to do. I just have to put that text in.
Yep.
That was not the intention initially on this document, because we didn't want to change, you know...
Well, you've either got to do that, or you've got to say that delete the paragraph, delete the section, or delete the body of the section and say, the method for doing this is described in RFC whatever.
Well, yes, okay, but here's the problem, is this document is well established. The procedure in this document is well established. This is ready for, proposed standard or standard track, right? Those RFCs, they updated, like the control board updates and so forth. That is not exactly the same status. So
We need to go through each one on a case-by-case basis and see, because that line will not be, that line of updates will not be present in the new RFC.
Right, okay.
So we need to make sure that the reader of the new RFC
Right.
is aware, by reading that document or reading another document, of the work that is presented in the update text.
Okay, but this still gives me a dilemma, because the control board negotiation procedure that this is describing that is not in this document.
Right.
And it is not the same status level of implementation or anywhere than it is in this particular. In fact, I believe that there might not be any implementations of what is in this document. So I can't really include that text in this document and claim that this is.
We should look at this offline, but we do need to deal with the updates as well as the errata.
Yeah, sure. We'll deal with that. We need to figure out how to best. Reference maybe or something like that, so we don't have to do something that causes the document to linger yet another 10 or 15 years. Okay. So any other points? I'll note the updated points. Is anything else anybody wants to bring up? I've asked for this 10 minutes because usually we don't have enough time, and I wanted to kind of add the conclusion and discussion to move this forward.
We have all the time in the world today.
Sorry?
We're going to hijack another hour and a half or something at the end of this.
Yeah, we have lots of time.
Yeah, exactly. Eric.
Yeah, I have one comment on.
Name, please.
Eric Gray at Ericsson. I have one comment on the thing you were talking about with the order of the TLEs, and it seems to me that there's sort of a proof of concept that there's some confusion over this, and you could argue that because we don't say it has to be in this order, right? We are implying that it can be in any order, but it's equally true that if it's shown in a specific order, it's implied that that's the order you might be expecting it in. And so I think it might be useful to put in these may appear in any order in the document. On the other point, you were just talking about with the updates. I completely agree with the chairs on that. I mean, minimally, after all things are considered, you have to at least put a paragraph in there that says, please also review the following RFCs, which have updated this.
Sure. Yeah.
Okay.
So about the order, the comment I have is that earlier in the draft there is actually a set of TLVs with a picture that has to be in order, and it says this has to be in the order. It explicitly says that. So the rest, I mean, people, yes, can assume the next one has to be in order or not. I mean, it's kind of a clarification point. We can, I don't have a problem to add some text. We could add a text that says, this don't necessarily have to be in order or something like that. But the interpretation is that they shouldn't be in order, and the text doesn't say in that section that it has to be in order.
So I think that would be extremely useful clarification, because one of the things that people tend to forget is that when you have a may in an RFC, there's an implicit must behind that, which is that you say it may appear in any order. That means somebody must accept it in any order.
Right.
So.
Any more comments?
Okay.
Great.
Any more
Thank you.
questions or comments for Luca? Okay, thank you, Luca. Let me put the next presentation up. That is, yes it is. Just move it a little bit to the left. That's fine, thanks.
Okay.
Loa, could you use the microphone?
So there is a directive
What's your
from
name, please?
Loa Anderson. There is a directive from the Secretariat that we should make the speakers keep within the box on the floor because there is a camera there that's actually running. So please.
Thank you, Lois. So, if you come up to speak, please stand in the
This
pink box.
Pink box here.
And remember that
If
for
you
the
step
week
out,
as
you
well.
get zapped.
Yes.
Okay, so I'm going to talk about MAC withdrawal signaling. These are the co-authors. So brief history. We started with this effort was started in 2011, and it was first presented in L2VPN. Then it went a little bit dormant. There wasn't sufficient interest in the L2VPN group. The service providers were requesting this feature, so I picked it up and presented in PWE3. In PWE3, we went pretty far discussions, and there was a lot of acceptance and all that. In 88, IETF 88, we did a detailed protocol presentation, and it was well received. But at the end, almost towards the end, there was I think the chairs, Andy Mallis and other people suggested that we should really take it to L2VPN working group. So again, we took it back to L2VPN working group because original MAC withdrawal signaling for dynamic pseudowire were actually done in the L2VPN working group. So we took it to the L2VPN working group. Since we were already in the last stages in PW3, we did a last call, and I think then the group split. We had some more comments, and so this is an update on with the comments. Next slide, please. So as you guys know, MAC withdrawal signaling is actually it's an optimization to mitigate the black holes during pseudowire switchover. It's already done for dynamic pseudowire, as I said. This is to do it over the static pseudowires. So this mechanism actually is cloned from the dynamic MAC withdrawal signaling which is already defined in 4762, and pseudowire status signaling was actually taken from the pseudowire status signaling actually shows how you can do the status or any kind of signaling on the OM channels. So we took that scheme from there. So yeah, here's just a brief graphical display on where it is used. A little bit of animation here. You want to click?
Yep.
So if you have a fault, if MTU is dual home to PE1 and PE2, and if the primary pseudowire is on going to the PE1, and if you had a fault, you need to the MTU switches over to the standby pseudowire. One more click. And since this is a static pseudowire, you need to do a signaling of MAC withdrawal. One more click. And so this is how it progresses. MTU sends the MAC withdrawal signal over the static pseudowire as described in this draft, which then gets propagated to all of the remote PEs. The whole idea there is the whole idea there is that all those remote PEs, PE6, 5, 4, 3, 2, who were sending the traffic for stations behind the MTU, those remote PEs did not know anything about the pseudowire going down on PE between MTU and PE1. So they had learned the MAC addresses that was sending the traffic to the PE1. So they would continue to send traffic to PE1. We want now to let them know that now that you can send the traffic for the MTU through the PE2, so you need to send this MAC withdrawal. That's the utility of this feature. Okay. So the why on the static pseudowire? So this MPLS TP, is taking hold, especially in the access networks. and that's static provisioning LSPs, and that dovetails with the static provisioning of the pseudo wires. So this necessitates this OM signaling for the static pseudo wire. Next. So the coming back to the central topic here, the response to the comments. These comments were quite comprehensive, and Stuart provided those. So thank you, Stuart. I have not addressed all the comments, but I have taken the most of the general bigger comments. The first concern was that MAC withdrawal signaling on LDP was actually, LDP uses the TCP, so there's a guaranteed delivery, reliable, acknowledged, in order. And this one, since this is not using TCP, it's over the static pseudo wire. So how do you guarantee the delivery? And so the comment is correct. We do have the sequence number, acknowledgement, and 3 retries. So it's a kind of a best effort scheme. It is true that yes, you can, if the network is congested or lossy, you can lose that, and you may not get the MAC withdrawal signal.
So
Yeah, go
I
ahead.
can't remember what the new text says, but does it explain clearly to reviewers that it is a best effort scheme? Because
Yes.
the danger is this question will get raised
Yes.
3 other times between now and an
Yes,
RFC.
I actually added a paragraph because you made that comment. I said yes, I will, and I added, yeah, I made it very, very clear that this is a best effort scheme. It's an optimization scheme, and there are other mechanisms by which the node will relearn. So if you have a bidirectional unicast frame exchange going on, then you will relearn. And the second is the aging timer. Go ahead.
Sorry, Sharon Davari. So a question, what's the difference between this and this RFC 7361? And also there was an EVPN MAC withdrawal also. What's the difference with that one?
So the 7361 is an optimization. In the 7361, the scheme there is that if we go back to the previous diagram, that graph, here in 7361 says that the P1 should send the MAC withdrawal.
Okay.
Instead of having the P2 send a MAC withdrawal to everyone, the P1 sends the MAC withdrawal with a specific list of MAC addresses, so that you don't have to flush all the MAC addresses from the other.
But here you flush everything.
Yeah, so this is for I mean, this is the MAC withdrawal signaling original 4762. This is what it says, that you do it on the one you just activated. So that's the difference.
And then EVPN also had some MAC withdrawal.
I don't think that there is anything different there. They are, the BGP based MAC withdrawal signaling. Yeah. EVPN is BGP based.
Okay.
Yeah.
And this is LDP based.
This is LDP based. No, this is static.
It's static.
This is on the OM
It's static,
channel.
not even LDP.
No, not even LDP.
But your draft says LDP based at the beginning.
No, the scheme is derived, the MAC withdrawal signaling scheme, the MAC list TLV, is derived from the LDP based MAC withdrawal. We didn't define a new TLV.
Okay.
But this is done on the static pseudo wire on in-band OM channel. So we are
In-band OEM channel. So
Yeah.
you're defining a new OEM
Yes,
channel, for
yes.
a new ACH type.
Yeah.
Yes.
Oh.
Yes.
But it's not in the draft. I think
It's in the
is.
draft.
It is?
Yeah, and actually the last slide says we are asking for new OM channel type.
There's seats towards the
Maybe
front.
I should make that clear too. It says the static over static pseudo wire. There is no LDP. In band, yes. Yeah. Okay. A couple of slides more. Yeah. So the general scheme is that you will relearn with the bidirectional unicast frame exchange, and obviously you have the MAC address aging. Usually the default time is 300 seconds. So in the worst case scenario, you would have a black holing for 5 minutes. Another point is that you don't want to actually keep retrying forever, because the utility, the benefits of MAC withdrawal signaling to flush MAC addresses decays as the time goes by. So, it's a very small window. You want to do the flush and, carry on. Okay, the next slide, please. So the other comment was, what if you're using the big Mac, if the list is too big, there's no fragmentation, and, how do you handle all that? So, the response is actually there are a couple of ways you can handle that. One is that it is a sequence number based, so you can treat a concise, you can break up the list and you send frame by frame with whatever the list it can accommodate in the MTU. And each one is treated individually with the sequence number. The other thing is that if it's too big, you just use an empty MAC list.
Sorry, I should share on the very.
Yeah, go
So
ahead.
how does the P2 now know there's a failure on the other link?
There is a pseudo status signaling also. So P2 really doesn't have to know that there was a failure between MTU and PE1.
And then why, if it doesn't know, then why should it ask for a MAC withdrawal?
P2 doesn't ask for it. MTU sends the MAC withdraw to the PE2, and the PE2 then forwards that to everybody else.
So this packet that you're just showing is sent from the
MTU, yes.
not from PE2.
No, not from PE2. P2 forwards it.
Oh, so the MTU, so the pseudo wire, it starts from MTU?
Yes.
Not from PE2?
No. MTU is, the hierarchical VPLS, right? In the hierarchical VPLS, you have the... It's not a multi-segment pseudo wire. This is in the hierarchical VPLS. You have an MTU that talks to the PEs, and the PEs, it's... Yeah. So the MTU would send it over the pseudo wires. Let's go back.
Okay. So the MTU sends it over a pseudo wire which terminates at PE2.
Yeah, exactly.
And then the PE2 takes this message and puts it on another pseudo wire.
On all these pseudo wires that are going to the VPLS instance, yes. Same thing with the pseudo wire status signaling and all that. Yeah.
Sorry.
Yeah.
Okay.
For those of you who are standing in the back, could you find seats? There are some open seats up here. We don't want to keep the door blocked.
Yeah, it's a
great. Thank you.
This is very common. Yeah. I can explain you more offline if you want. Okay. We'll go back to the comments. Yeah, so you handle the the MTU exit by either empty list or break down the list into multiple PDUs. Okay. The second, the next slide, please. Yeah, sorry. There was the concern is how do you handle the out of order? Again, this is not a reliable delivery, but we do have a sequence numbers. So what we have stated in the draft is that if you have out of order, so if you have a lower sequence number arrive later than the higher sequence number, you actually ignore that, but you do ACK it. So the higher sequence number takes the precedence. So now when that happens, if you ignore that list, you will not flush the subset of the MAC addresses, which again is fine, because then if you did miss those MAC addresses, they would be relearned anyway by other mechanisms. So, it's not a calamity that you lost a subset of MAC addresses. Next slide. The fixed three, we do the 3 retries. Actually, can you go back? I didn't talk about the sequence number wrap. There is an RFC 4385. We do sequence number in the control word, and this RFC 4385 actually describes how do you handle the wrap, how do you detect a wrap, and how do you handle it, the overflow. So I'll go to the next slide. Okay. So yes, we have three retries. The comment, the fixed interval. So the original draft said that if you don't receive that, if the sender doesn't receive the ACK, you resend after 1 second interval, 3 fixed intervals. And the comment was that, in case of scaled configuration, there may be many pseudo wires doing this, and you cannot guarantee that every. So I think the better thing, and I've changed the text, is that you can do the exponential backup. It's an implementation choice, but it's a suggestion that if you were to apply some jitter, then you have a better chance of resending it and getting an ACK back. Next slide, please. So yeah, I mean, we had that was very good comments, very comprehensive. There was a lot of other comments also. I haven't addressed them all here, but it made the draft better, and I think we feel that we have it's now in a much better shape. So next slide, please. Yes, so I think we have asked for a new channel type X28. And we feel that we should go for the last call again. Any comments? Yes, sir.
Again, two more questions. Well, I don't like the name OEM. I think maybe you should change it to something else. You call it OEM. This is not really OEM.
The pseudo status also calls it OEM.
OEM?
Yeah.
Yes. It's consistent, Sharon.
Sorry?
It's consistent.
It's consistent with previous errors.
Yes. It's
back to
consistent
back to back compatible.
RFCs.
Okay. Okay.
Well, if you feel strongly enough about it, I suggest that you put your comment on the list and see if you get any positive reaction.
Yeah, because this is really control messages, not OEM. It's not doing any.
It will go to you send a comment in.
Sure.
It'll either be before or during last call. It will be addressed according to due process.
Sure. Second thing, is this only withdrawal, or is it can it be used to move the Mac to a different pseudo?
No, it's only for withdrawal.
It's only for
yeah.
It would be. I mean, this is kind of an imperfect solution intended to provide some optimization.
Yeah.
If it was a movement, it would need to be.
It will have to show where to move to and all that stuff, and the sender doesn't know where it should move to. Like for instance, in this case, then PE2 would have to know which pseudo wire failed and what that pseudo wire coincides on the other remote PEs, right? Here, this is just saying, hey, flush this, make it unknown, it will get broadcasted, and it will relearn. The whole idea here is that don't keep sending it to the old path, because old path has gone down. It's not gonna go. So that's the whole idea here.
Okay, great.
Thank you.
Thank you, Himanshu. And the chairs are in agreement that it's ready for last call. So that will be starting soon after the IETF.
I did.
Excellent. And just before we move on to the next talk, who has not yet signed the blue sheets? I see a lot of hands up. So whoever has the blue sheets, please start them circulating again so we can get them around to everybody.
Okay.
Anything else?
Yep, that's it.
Okay.
Right, so I am not Carlos or Prasad. Yep. Oh.
Yes.
Ah, okay, I stand in the pink box, okay.
Okay,
Trapped, really.
for those of you, just for everybody's knowledge, for those of you who plan to present in any working group, in any room this week, there is this Meet ecosystem that the IETF is now using and I think every one of the rooms now to broadcast what's happening in the IETF and record it as well. And there's a little camera in every room. And by standing in the pink box that's marked on the carpet, that guarantees that you're in the range of the camera so that anyone who's watching out in the web or watching the recording at some point in the future can actually see who's speaking. So that's the reason why there's a pink box on the carpet. So now you all know.
Well, that's all very well, but and it's fortunate that in this particular slot, I don't need to do my usual thing of pointing at the slides and explaining one line or the other or showing how packets are moving around. So we should provide some feedback about this restraint on speakers. Okay, next slide, please. And I'm not either of the, and this was presented in BFD yesterday. Next slide, please.
It should be moving. Let me see. Hello. Here we go.
Okay. So what
Dave, pass it right behind you.
what this is about defining the behavior of SBFD on the VCCV channel for signaled and for static pseudowires. And slightly unconventionally, it covers both the L2TP case as well as the over and MPLS PSN case. So 5885 covers this, but we don't very often talk about it in this working group. So we're interested in L2TP signal pseudowires, static pseudowires, and a future revision of the draft will talk about LDP signal pseudowires, but it's not in the current version of the text. Plan is to reuse the encapsulation and protocol procedures of 5885 and to define the additional work, changes that are needed to support SBFD. We will need a new CV. We need new CV types to support SBFD async. SBFD echo is not in scope. Now, we had this discussion the last time this was presented. It's in the records, and the authors will take a look at the echo issue. SBFD provides VCCV-based fault detection only, and other fault detection status signaling is out of scope. Next slide, please. So the next thing that we need to design as part of this is the mechanism for getting the SBFD discriminators. We'll either use provisioned discriminators or use the alert mechanism that's currently being proposed in the seamless BFD alert draft. And L2TP, when that's used for advertisements, there is a draft that describes how we add that to L2TP. Encapsulation, where as you recall, we can either send BFD natively or we can send it in UDP-IP. Where it's going in UDP-IP, it will go sort of as it does today, except that the SBFD UDP destination port will be used. So that's actually really just cookie cutter stuff. Where L2SS for L2TP or the pseudowire ACH encapsulation mechanism is used, we will have to request new IANA types to identify that it's SBFD being carried. Next slide, please. The initiator operations, we need two new CV types for the operation. Option 1 uses some reserved bits in the existing parameter defined by RFC 5885. Option 2 uses some bits from the VCCV extended CV parameter TLV defined in RFC 7189. For the reflector operation, the proposal is to run this exactly as described in the base BFD seamless specification. For capability selection, and this is something that I think we need to discuss in this room for a little bit, there's a question of what is the order of preference between SBFD and BFD, and I understand that you can have both of them concurrently working as well. So the question that the authors posed in their original slides was, can they be independent, i.e. no order of preference? as someone who's worked in this working group for quite a long time, I would be worried about that, because I would like to make sure that every time two systems come up, every time I provision some systems, the behavior is exactly as I expect. So I'm guessing we may end up with all three cases, one, the other, or both.
Greg Mirsky, Ericsson. Actually, I would compare SBFD to ICMP and LSP ping, so not really a BFD, because it's a functionality of echo request, echo reply, and that's more like ICMP ping and LSP ping.
Right, but we're going to have to, but the two signaled pseudo-wire PEs, or whatever you call the LTTP one, I'm sorry, I can't remember, they will have to have a common agreement whether they are going to run just BFD, SBFD as well as BFD, or just SBFD, because they could decide they only want to run SBFD. Yeah, all three possible cases exist.
Right, but at the same time, when we're advertising capability, we're advertising ICMP ping and LSP ping. So
Andy Malice, I just have a comment as a participant rather than as a chair. My own personal druthers is that we as a working group just make a choice for one being the default, one of the three cases. I don't have any particular opinion as to which one should be the default, but I would like to see a default, so that if people just naively bring up systems without provisioning this, it'll work.
Yeah, I absolutely agree. There needs to be one default, but I suspect there are really three cases and not two, as people may have thought.
yes. I have a question to the previous slide where there's a reference to ACH encapsulation. Previous slide. So in case of ACH encapsulation, there is no IP address to return to. So how Reflector will identify the source of SBFD echo request and return, because the idea of SBFD is that Reflector doesn't create any state associated with the session.
There is always pseudo-wire state. I mean, yes, there's unconditionally going to be pseudo-wire state, because pseudo-wires are always bidirectional. So you always know who your peer is.
Okay, so basically,
I think you can say that you always know that if you get something of this type, of the SBFD type, on a pseudo-wire, then you take the appropriate actions and send them back on the reverse part of the pseudo-wire, because pseudo-wires are always bidirectional.
right. Okay.
I'm not quite sure what happens, and maybe maybe I've just forgotten, what happens if you have a point to multi-point pseudo-wire. Do you always have a return channel there? I really can't remember.
No.
No, so we do need to figure out whether this is applicable to that case.
Yeah, the only thing that you really know is that there's probably an IP return channel, and that's about all you know.
Well, I don't know. There may not be any in an MPLS TP one.
That's true.
There may not be anything.
That's true.
So we do need to have some comment in here on that, either limiting the applicability or solving the problem.
Yep.
Okay, next slide. So I think it would be really useful if people can put some of the comments that they've made onto the list. It would be good if we can have a list discussion on this. The authors are keen to close off the open items and to submit a new revision, and they're going to ask for this to be adopted by the working group. Given the existence of SBFD, I think the working group does need an opinion on it, and does need to specify a solution for using that type of OEM technology. Okay.
Okay. Any
other questions?
Robin from Huawei. I have a question that is, it mentioned in the previous slides, it seems that is not considered the LDP-based L2 VPN.
So this again?
that means LDP-based L2 VPN is not taken into account in this draft.
Hang on. So
Is that
pseudowires
right?
don't use RSVP signaling. There's no definition of an RSVP signal pseudowire. Is it? No. Not one that I've noticed. So I don't see why we need to have any discussion about RSVP here.
No, not RSVP, LDP.
LDP.
LDP. Yeah, why not?
So they plan to provide some text. I think if you go earlier on in here,
Yeah.
MPLS LDP signal pseudowires are not considered in this revision. They bracket future. I understand that to mean that there will be an LDP body of text written before this work is fully completed. So we will need an LDP solution, and hence, my question about how do we pick one if we're negotiating this, because if you're running LDP, you will have to have the default negotiation mechanism working. So I think it's just that they didn't put the text in, rather than there's no intention to do it, and I think we have no choice but to solve it, to document the design for use in an LDP signaled environment. And I'm sorry I misheard that you said RSVP.
Okay. Oh no.
Any other questions?
Shah from the Valley. Just a clarification question. These runs over the L2TP has a control packet and data packet. It runs over the data packets, right? Not the control.
So the signaling configuration runs over the control plane, and the identification that this is an OAM packet.
The SBFD itself runs on the data.
There's a bit in the L2TP header that says this is OAM.
Okay.
So it has exactly the same concept, but it just does it in a completely different way.
Yuan Longjiang from Huawei. Just a clarification. Is this dropped the purpose is to replace the original VCCV BFD?
No, I don't think so. I mean, BFD exists anyway, and I can't see us ever deprecating it in any immediate time frame. So this is to enhance BFD. Presumably when you want to introduce some measure of scaling that you might not easily achieve with BFD. But BFD has got some useful properties anyway.
Yeah, I agree. But such job said that it can also be used to MPS cedwire. So I think we have two options for the BFD VCCV. So which should we use?
Sorry, I'm not sure I properly understand the question.
He wants to know that there's going to be two options, BFD and SBFD. He's looking for guidelines.
I think it depends on what you're trying to achieve.
Yeah, so I think his point is that the draft should go into.
Oh, right. The draft should discuss under what circumstances you would run one or the other.
Yes.
The applicability of the work would be a useful section to add.
Yeah, sure.
Yes.
Exactly. Yeah.
How to choose it if both are supported in the same equipment?
So the answer is I don't know the answer to that question, but I asked the authors, shouldn't you have A or B? And they said, no, I might want to run A and B. So, and I didn't pursue it. But if they tell me they need to run A and B, we need to figure out how to get both ends running in the same mode, A, B, or A and B. Okay. Anything else?
Great. Any other questions for Stuart? Okay, thank you.
I'll stop being a ghost.
And just before we move on, does anyone need a blue sheet? Yep. Eric, could you pass it over to that side of the room? Okay.
Hello, Robin from Huawei. This topic is to discuss the design for L2 VPN young model. Okay, I think next slide. Okay, this is the history review. In the Honolulu IETF 91, so we presented the L2 VPN young configuration model in the past working group. Then after the meeting, we received a positive response from the several experts to cooperation to define the YANG for L2 VPN. So because the working group is changed, so this draft is also moved to the past working group to get the appropriate working group to go on to discussion. Okay. So we have a meeting to discuss the design for the L2 VPN YANG. So according to the cooperation, so that we set up a design team for L2 VPN YANG. So this is from Xufeng, Santosh, Kishore, and Himansu. So and also that we go on to welcome more members and cooperation from the industry. We hope to at the beginning to negotiate the common models for L2 VPN YANG so that we can finish the YANG work and get the consensus at the beginning. Okay, next slide.
Thank you.
Okay, so the design team, we discuss the scope of the L2 VPN because in the past 10 years, L2 VPN is very popular and all kinds of L2 VPN solutions have been proposed. So the scope, we try to define what to design by this team and what not to be designed by this team. So the first is the scope is the common comments for the L2 VPN. So that means no matter LDP-based, BDP-based, or the static-based. So we have some of the common configuration. This include the L2 VPN instance and the attachment circuit and the sealed wire. This is the basic components of the L2 VPN, so that the common configuration and operation will be defined. And then the YANG on the different types of the L2 VPN, because the different L2 VPN, different types of the L2 VPN, there may be different configuration and the operation data. So this include the LDP-based VPWS and the VPRS, and the BDP-based VPRS, and the BDP auto-discovery-based VPRS, and also that the static VPWS and the static VPRS. So this is the types of the L2 VPN will be taken into account. So now the one remaining issue is the CCC. That means the circuit cross connect, because this is to some extent is different from the common reference model of L2 VPN. But in fact, there are several implementations. So we will discuss later. This is used as a vendor-specific YANG model or try to define in the working group. Okay, next slide. Okay, so this YANG definition, we will take into account the configuration data and the operation data and the RPC and the notification, so that is complete the YANG definition for the models. Not in the scope. I think that the L2 VPN, because the number of the types of the L2 VPN, so I think this can be a huge draft. So and also that is some work related with the L2 VPN or the sealed wire E3. That means that the OEM, they have the VCCV pin and the trace, and also that MPLS-TP OEM for sealed wire, especially regarding related with the performance monitoring. So this work will not be taken into account by this team. So this work we will leave to the OEM experts to do the YANG model work. Yeah. Okay, next one. Okay, and also when we present the work in the past working group, but in fact the R2 VPN has much relations with other work. So we will do during the course of the design, we will do the liaison work. This includes the liaison with the BES working group, because the BGP-based VPRS and the BGP auto-discovery-based VPRS will be taken into account. So the liaison work will be done between the PAS working group and the BES working group. And also that is in the last meeting, Stewart reminded us that the R2 VPN, the existing R2 VPN MIB, so this will, when design the young model, so we try to keep consistency with the existing R2 VPN MIB. Okay, and this is the design work plan. So the first, we will discuss the architecture design, because firstly, we try to define the architecture of the R2 VPN young models. So we tried to finish this work in the middle of May this year. So this defined, the work include scope definition and also the component division, because we try to divide the R2 VPN young model design work into the different parts. So this is into account. This include the common component and also the different. There may be different draft for the different R2 VPN young model. So this is the two works will be taken into account into this phase. After the phase, so we will prepare the plan for the concrete data model design. So the concrete data model design include the common component and the specific paths of the different types of the R2 VPNs. So I think we tried to propose the initial draft before the next IETF meeting. But according to the past experience, so the work is very challenging, so that we will propose a work plan after the first phase architecture design, so that discussed in the working group to see if it can comply with the charter of the R2 PAS working group. Okay, next one. Okay, so this is the working method that has been discussed in the design team, so that we will meet every 2 weeks to discuss the design of the R2 VPN young models. Okay, I think this meeting time has been determined. Any comments?
This is Bingwen from Comcast. I have a question for the scope of work. So I see you cover BGP-based VPLS. I'd like to understand, like, will in the scope you also cover BGP-based VPWS service? So the point-to-point.
Yeah. Okay.
So the question is, you cover it under the spec in RFC 4761, or are you cover also 6624?
I think that should be covered, because yesterday we also discussed the BGP-based VPWS. Yeah, it's be covered.
Okay, yeah, we as Comcast, we use BGP signal VPWS. So I definitely want to make sure, like, this be added to the scope.
Yeah.
Okay.
David. Okay.
Thank you. Can we go back to the working methods? One of the things I'd like to see as part of the working methods is that you update the wikis that we made reference to at the beginning of the meeting. I know there's quite a few drafts on there, and I'm not sure which ones overlap. It looks like there's some redundancy because some of them are listed as L2 VPN and some are listed as PALs, but if you could reconcile those as a result of the work and the working methods, I'd appreciate it.
Okay, yeah, okay, definitely. Okay, I think that we will, that in the beginning slides, that the young model coordination work method has been proposed in the IETF. We will comply with this method, okay, during our work. Okay, next one. Okay, so I think this is finished. So I hope that we get more comments to help us to define the young models effectively.
So would you like to participate? We need service providers to participate in this activity because they are the one who are using these models, right? So it would be really nice if service providers join this effort.
Yeah, I think at Comcast we are heavily investing looking in net content again. So definitely I'm going to have someone from our development team participate.
Iftikhar Infinera. In the scope, question for the scope,
Okay.
is at the service level aspect of L2 service, for example, like manipulation of the VLANs, for example, or end-to-ends, in the context of L2, are they in the scope of this one or not?
Okay, I missed this point. In fact, in the last meeting, they proposed a similar opinion. So that is because for the VPRs, for some of the VPWS, there are some of the special configuration regarding the AC attached circuit. So that especially for VPRs, there's a lot of the VLAN operations. So this work will be defined in this model. Yeah.
Nick Del Regno, Verizon. Couple things. One, be happy to help out with the definition, so I'll send you an email and join the list. The second is, don't think we should include vendor implementations, vendor-specific implementations like CCC in our definitions. We should be in the business of writing Yang models for the RFCs that we produce.
Okay, we will take into account.
Greg Mirsky, Ericsson. I think that it's okay to have containers where their specific implementation details can go. But Yang model, the standardized, should be a common set of functions.
Okay. Thanks, Jeff, for comment on that. Andy Malice. This actually takes me back to a little bit of history that I can tell you all. Back in the 90s, here in the IETF, I chaired a working group where we did an S&P MIB for frame relay services. And there was also, in the ATM working group at that time, we also did a very similar ATM MIB for ATM services. In each of those MIBs, we did have a vendor-neutral cross-connect table. So I suggest that you might just want to take a look at those two MIBs as examples of what you can do for a vendor neutral cross-connect.
Okay, thank you.
Okay, any other questions or comments before we move on? Okay. And we'll come to our last presentation for the day, which means we are running right on time in terms of finishing up in an hour and a half. Although we do have the full 2.5-hour slot, it turns out.
We requested 1.5. We're supposed to be sharing the forces and forces destruction.
Okay, let me just start these up. And Mohammed, take it away.
Okay, so my name is Mohamed Boukader, so I'm presenting this draft on behalf of the authors. So the presentation will be short because this working group and the framework group that did already done the work to identify the problem space and the gap analysis that we are addressing in this draft. So in the next slide, please, as you see in the RFC 7439, it identifies what are the missing pieces so that we can deploy an IPv6 enabled MPLS network. And in that excellent analysis, they identified that the only piece which is still missing is RFC 6074, in which they even identified the section that need to be fixed and handled so that we can have something which is address family independent while we have it right now IPv4 specific. So this draft is trying to fix this void. So it suggests two simple updates, as you can see in the next slide, please. So the first one is just an update to the BGP in NRI attribute that is defined in that section. So in the current version of the RFC, the P address is only encoded in 4 octet. And the new, what we are suggesting here is that to have the P address encoded to cover both IPv4 and IPv6. So there will be some text to explain all this in the draft. And the next update is related to the signaling part, the signaling part, in order to be sure to use an IPv6 address as an attachment identifier, both as a source and a target. So the draft is suggesting to define a new type, which would be able to include 128 bits rather than the one that is today only capable to do 30 bits. So there will be a section that will need to be updated in the RFC 6074, just to say that we can use either type 1 or type 2. So as you can see in the next slide, please, this draft is just filling something which has been identified in the analysis RFC. The fixes are, for me, not controversial, are straightforward. So we are presenting here in this working group to seek for more feedback for you and suggestions so that we can move this document forward. So any suggestions are more than welcome, please.
Very nice work. This is quite useful. So thank you very much for doing the work. Are there any questions? Comments? Anything at all? Okay, thank you very much.
Thank you.
And with that,
You have an extended lunch break.
yes, that brings us to the end of PALS. So thank you all very much for coming, and we'll see you next time. Oh, whoever has the other blue sheets, please bring them up to the front of the room. Yes.
Yep. I handed it up to you.
They're around somewhere. Oh, I see them. No, there's 2 total.
There's 2 of these black things.
And the other one, I just saw someone hold it up. It's not. It's back there. Thank you very much.
Yeah, we're working on the DW homing drugs. You remember you presented last time? Oh, yeah. Pretty good. I think the finished the adoption process. I will ask whether they can be adopted. And this afternoon, I'm not working. And we can go and maybe they need some. Thank you.
Oh, that's funny. That is funny. I will turn this into the secretary. Yes.
BGP, basically BGWS, I think the silverware is the same with the APRS, either just the AC. CEID. Okay. So it means the VPRs, you mean the site ID.
Right, yes.
Okay,
So
okay.
VPR was only need to worry about so I don't
Thank you.
maybe like
You are the first.
Okay, okay, no problem. I thought
I'll find the draft, like I find the information and I'll just down to conversation.
Okay, okay.
Yeah, great. That's
So Robin, there are a lot of people going to join the Yang one.
Okay, yeah, no problem.
He's from BPR.
Yeah, I see. I have a
And
take a
Matthew?
photo. Okay, okay, yeah. I see, yeah.
So we need to sort of organize
Okay.
maybe
Yeah.
identify
Yes,
all
okay.
or arrange an outbreak.
I'll send you. So
Okay.
Commence
on
For me, yeah, the most important thing is in that itself.
Yeah, because it is just really good rule, because one of those places have the consensus.
One of those drafts that has. And so I think what this is going to require is a discussion between me, Stuart, the best
Decide which.
yeah. So I assume you're planning on presenting the best.
Yes, I will present more.
Cool. So after you present, why don't you do us all a favor? Please send an email to the podcast. You know, Stuart, me, the best please find me at home. And I promise you, we will find a way. But obviously, no matter which one is home.
Yeah, I understand. But the problem is that there is nothing there which is the rocket science. Just straightforward technology which is already up there. And yeah, just do it. It's done then. So yes. Yes, I thought that's here and excellent from there. Thank you very much.
I see. Right.
That's okay.